So we've seen what happens when the electricity gets to our homes and we plug in our appliance to our wall. But how does the electricity actually get from the power stations to our homes? And this is through the national grid. So the whole point of the national grid is to transfer electrical power from the power stations to our homes. And the way it does that is through a system of cables and what we call transformers. And if you're confused what a transformer is, I do recommend you watch our video on magnetism and electromagnetism, where we went through transformers and how they work. But essentially what a transformer does, it can change the voltage or the potential difference in your current of a certain current source. And so let's have a look how the national grid works. So what you'll start off with is a power station. So let's draw a box to represent our power station, and we'll do it in red. Red is powerful. So this is your power station, and the idea is you generate your electricity here, and you might pump out your electricity. And let's say you generate the electricity at a certain current and voltage, let's say 1000 amps at 25,000 volts. 1000 amps and 25 volts. And then what happens is it goes through a step up transformer. And so again, let's draw a shape for a step up transformer. Let's use this shape because why not? So we have our current flowing through a step-up transformer, and then what the step-up transformer does is steps up the voltage, and therefore the current then decreases. And so instead of having 1000 amps and 25,000 volts, you might step it up to 400,000 volts, and then therefore just 62.5 amps. And we'll look into why this happens in a second. But then essentially this step-up transformer, it steps it up, and then these cables are transported very close to our homes, and then we get our step down transformer. So once we get to our homes, the idea is that we don't want to have this very high voltage, very low current. We want to step it down to a usable voltage and current, and so we'll use a step down transformer to achieve that. And so then at the output of the step down transformer, you will get the expected current and voltage. So remember, we know from mains electricity we have a voltage of 230 volts, and the main thing really we're interested in is the voltage at this stage, and then it goes to our homes. So we can draw a nice home over here. These are our homes, or it can be even not necessarily a home, but also maybe factories and things like that. So that's our home. And that's basically the way the national grid works. You have your power station, you have your step-up transformer, you have your step-down transformer, and finally you reach the home. So what is the reason for having this stage here? Why not just cut this stage out and transport it directly from the power station to our homes? Or even if you want to step it down to a usable voltage, why not just have it step down to a usable voltage and then transfer to our homes? Well, the idea is that this section here is quite important. From the step up transformer to the step down transformer, that is the largest distance. And if we transport the electricity over this large distance, over these large cables, then what's going to happen is there is some resistance in the cables, and it's going to cause the cables to heat up. Now, what we know from energy transfers, that heat energy has to come from somewhere, and that's actually the electrical energy being transferred to heat energy. And this is a form of energy loss, if you like, because we're transferring the energy from our electricity to a less useful form of heat energy. We don't really want that heat energy. And one way we can prevent that is by increasing the voltage, because when you increase the voltage, what happens is you decrease the current, and what that does is you decrease the amount of heat that you generate. So the amount of heat that is dissipated through the cables is reduced. If you were to transport it at a much higher voltage, at a much lower voltage and a much higher current, then what would happen is you would end up losing a lot of your energy, your electrical energy, as heat, and it would make the whole system much less efficient. So the national grid is set up this way because it's an efficient way to transfer that energy, and the reason being this key bit here, when you have a high voltage, you end up with a low current, and therefore you end up dissipating less heat through the cables. Okay, let's go through a few questions. Okay, just a few questions. Feel free to pause the video, answer these out loud, or write them down, and let's go through the answers. So question 1, the national grid is a system of cables and what? Well, it's a system of cables and transformers. So hopefully everyone got that one. Question 2, what is the role of a step-up transformer in the grid? Well, a step-up transformer steps up the voltage and lowers the current. The whole point of that is to allow the electricity to be generated at lower currents, and therefore you lose less energy as heat, making for more efficient energy transmission. Okay. Question number 3, what is the role of a step-down transformer in the grid? Well, once you have stepped up the voltage, what you want to do is step down the voltage again and increase the current to allow for usable voltages and currents in your homes and your domestic applications. Okay, so hopefully everyone got those correct, and I'll see you in the next one.